In 1.6, we talk about other types of equations. So let's go ahead and just jump into the first example, where we're asked to find all the solutions for 6x cubed plus 54x squared plus 120x equals 0. So right away, you already have it set where it's set equal to 0. So we're ready to start. The first thing you want to do is look to see if you can factor out your greatest common factor. So right away I see an x in each of these terms, so I know I can factor out an x. And I look and I see that each one of these coefficients in front of my variable is divisible by 6. So I'm going to factor out 6x. When I do that, that gives me 6x, and then in parentheses, x squared plus 9x plus 20, close parentheses, equals 0. So I've got x squared plus 9x plus 20 inside my parentheses, and I can factor that out. Now I see that I have a coefficient of 1 in front of my x squared, which is great. So I can put an x here and an x here. And I need two numbers that multiply to give me a positive 20 and add up to give me a positive 9. So I know both are going to be positive, and those would be 4 and 5. So now all I have to do is take each of these and set them equal to 0. So that means 6x equals 0, x plus 4 equals 0, and x plus 5 is equal to 0. And I can solve it. I get x equals 0, x equals negative 4, and x equals negative 5 as my three solutions. Now for the next problem, I've got x cubed plus 2x squared minus x equals 2. Now, the first thing I want to do is I want to move that 2 over to the other side of the equation. So when I do that, that gives me x cubed plus 2x squared minus x minus 2 equals 0. Now I want to look to see if I can factor out a greatest common factor, and here I do not have one. But I do have 4 terms, and whenever I have 4 terms, that's a big indicator to me that I can factor by grouping. So I'm going to group these first 2 terms together and figure out what I can factor out from these first 2 terms. And I see I can factor out an x squared. So if I do that, that gives me x squared parentheses x plus 2. Now I want to factor out something from the next 2 terms so that I'm left with x plus 2 in parentheses. Now if I look, I have a negative x and a minus 2, so I can factor out a negative 1, parentheses, x plus 2. Alright, so then factoring by grouping says I'm going to put the x squared and the negative 1 together. So x squared minus 1 times x plus 2. Now x squared minus 1 is difference of squares. I could go ahead and set it equal to 0, or I could rewrite it as x plus 1 times x minus 1, because it's difference of squares, times x plus 2 equals 0. Now I recommend doing it this way because a lot of people have problems with the principle of square roots to remember to take the negative. So people will often give me the positive 1 and forget to give me the negative 1 in the answer. Alright, so now I just take each of these terms and I set it equal to 0, and that gives me x equals negative 1, x equals 1, and x equals negative 2. So I have 3 solutions. Once again, we know that we can always plug them back into the original equation to see if the answers hold true. Now the next type of equation we're going to look at is called a disguised quadratic. Now you're going to see several different types of examples of these, and if you look in the lectures and resources folder for our class, you should see a couple more examples of disguised quadratics. Alright, so the whole idea with disguised quadratics is that I'm going to look at this term right here. And I want to look at this one to see if it is the square of the first term. And in this case, it is. So there are different ways we can look at disguised quadratics, different values we can have. Now we do something called u substitution. So I'm going to set this first value, u, equal to x plus 1. Now the whole idea of this is it makes it a lot easier for us to factor out. Now, could we do this problem the long way? Yes, we could FOIL out that x plus 1 squared, multiply by the 3, distribute the 13. It would just be a lot more labor intensive. Alright, so for this particular one, you could do it without this method. However, there are ones that you cannot do without this method. So you're going to see several examples in your homework. There are also, as I said before, some more examples in the lectures and resources folder of this class. Alright, so if u is equal to x plus 1, then u squared would simply be the x plus 1 value being squared. So I can rewrite this as 3u squared plus 13u plus 4 is equal to 0. At this point, I can use the AC method to factor this out. So hopefully you guys remember the AC method from intermediate algebra. So you're going to look for two numbers that multiply to give you the product of 3 times 4, so 12, and add up to give you 13. So that would be 12 and 1. So I can rewrite this as 3u squared plus 12u plus 1u plus 4 is equal to 0. Now you don't have to put the 1 in front of the u, but I just wanted to make it extra clear that the 12u plus the 1u gives you the 13u. Now we're just simply factoring by grouping, so I can factor out 3u from the first two terms. So 3u gives me parentheses u plus 4, and then I can just factor out a 1, and that gives me the u plus 4 that I already have. Right, so this leaves me with 3u plus 1 times u plus 4 is equal to 0. So I end up taking each of these and setting them equal to 0. So that means I've got 3u plus 1 equals 0, and u plus 4 is equal to 0. So for the u plus 4 equals 0, that gives me u equals negative 4. For the 3u plus 1 equals 0, that gives me 3u is equal to negative 1, and therefore u is equal to negative 1/3. Now we are not done, because our original problem doesn't even have the variable of u. So u is a variable that we have inserted into this problem. So what we need to do now is put it in terms of x. So we need to go back and look at, well, what is u? U is equal to x plus 1. So that means that x plus 1 is equal to negative 1/3, and x plus 1 is equal to negative 4. So I'm going to subtract the 1 from the x plus 1 equals negative 4. That gives me x equals negative 5. And then I'm going to do the same thing here, subtract the 1, and that gives me x is equal to negative 1 and 1/3, in other words, negative 4/3, both of which would be acceptable. So I've got two solutions, both of which I can plug into my original equation to verify that they hold true. Now the next kind of equations that we talk about in this section are equations that involve radicals. So when I have a radical, the first thing I want to do is I want to isolate my radical. I want my radical to be on one side of the equation all by itself. Now, if I have multiple radicals, then I'm just isolating one of them so that it is by itself. And then I will square both sides so that I get rid of my radical. Now note that if you have two, you'll have to do this process twice so that you can get rid of both radicals. And I'll show you an example of that on question 3 from this next example. Alright, so let's look at the most basic example here, where I've got the square root of 3x minus 2 is equal to 2. So the first thing I want to do here, I've already got my radical isolated so it is by itself. So at this point I am just going to square both sides. Squaring both sides will allow me to drop the radical, so it'll end up being 3x minus 2 is equal to 4. Then what I'll go ahead and do is I'll add 2 to both sides so I can isolate my variable. That gives me 3x is equal to 6. Divide both sides by 3 and I get x equals 2. Now I can plug that back into the original equation to see if that holds true, and it's very important, especially with the radicals, that you check your answers. Keep in mind that you cannot take the square root of a negative number. So if a solution ends up leaving you with taking the square root of a negative number, then it is not going to work. You also just want to check your answers in general, because there will be occasions where not all of them work. Alright, so here let's go ahead and just check it real quick. I'll check it in a different color. So that means I've got the square root of 3 times 2 minus 2 is equal to 2. So the square root of 6 minus 2 equals 2. So the square root of 4 equals 2. Well, that holds true. So that answer is good. Alright, let's look at the next example. Here I have x is equal to the square root of x plus 13, and then I'm adding 7. First thing I want to do is I want to isolate that radical, so I'm going to subtract 7 from both sides. That gives me x minus 7 is equal to the square root of x plus 13. At this point, it looks very similar to the first example, where I'm going to square both sides. Now, when I square x minus 7, that's the same thing as saying x minus 7 times x minus 7. So you need to make sure that you FOIL this out. And when I square the square root of x plus 13, that just leaves me with the x plus 13. Alright, so I'm going to FOIL this out. This gives me x squared minus 7x minus 7x plus 49 is equal to x plus 13. So x squared minus 14x, combining my like terms, plus 49 is equal to x plus 13. At this point, I want to set this quadratic equal to 0 so that I can factor it out and solve. So I'm going to subtract x from both sides, and I'm going to subtract 13 from both sides. That gives me x squared minus 15x plus 36 is equal to 0. So I need two values that multiply, because my coefficient in front of my x squared is 1. They multiply to give me a positive 36, but add up to give me a negative 15. So I know they must both be negative to multiply and give me a positive, but add up to give you a negative. And that would be a negative 12 and a negative 3. So my solutions are x equals 12 and x equals 3. Now we have just done quite a bit of work, right? I'm not going to just go ahead and submit my answer. I'm going to check my answer. You don't want to do all of this work to then end up with the wrong answer, whether one of them doesn't work or maybe both of them don't work, or maybe they both do work. You always just want to check. All right, so let's go ahead and we can start off by checking to see if 12 works. Let me just scroll over to the side a little bit. Alright, so I'm going to check to see if 12 works. So I'll call this my check spot. Alright, so that means that 12 is equal to the square root of 12 plus 13. And then I have that plus 7. So 12 is equal to the square root of 25 plus 7. So 12 is equal to 5 plus 7. So 12 equals 12. Well, that holds true. So 12 is definitely a solution to this problem. Now let's do the same thing with the 3. So 3 is equal to the square root of 3 plus 13. Then I'm going to add 7. So 3 plus the square root of 16 plus 7. So 3 is equal to 4 plus 7. So 3 is equal to 11. Well, that's clearly not true. So x equals 3 is not a solution. So I'm just left with x equals 12 as a solution to that problem. Alright, now the next type of problem we're going to look at here. Go ahead and draw a line so it stays all by itself. This one I have 2 radicals, so that makes my job a little bit more difficult because I'm going to have to square this equation twice to get rid of both radicals. Alright, so I'm going to start off initially squaring both sides because I already have one of my radicals isolated. So I'm going to square this side, and whatever I do to one side, I have to do also to the other. So that gives me 3x plus 1 is equal to, now keep in mind when I'm saying that we're squaring, it's the same thing as saying 3 plus the square root of x minus 4 times 3 plus the square root of x minus 4. Alright, so we can FOIL this out. 3 times 3 gives me 9, plus 3 times the square root of x minus 4. That's from this move right there. Square root of x minus 4 times 3 gives me 3 square root of x minus 4. And the square root of x minus 4 times the square root of x minus 4 just leaves me with x minus 4. Alright, so I'm going to combine my like terms on my right side. So that gives me 3x plus 1 is equal to, now if you look, you've got that 9 and that negative 4, so that's going to leave you with 5 plus x, and that's just from this x right here, plus, now I've got 3 square root of x minus 4 plus 3 square root of x minus 4, so that turns into 6 square root of x minus 4. At this point, I want to isolate that radical. I want that radical to be all by itself. So what I'm going to do is I'm going to subtract 5 from both sides, and I'm going to subtract x from both sides. This leaves me with 2x minus 4 is equal to 6 square root of x minus 4. Scroll scroll up so we have a little bit more room. Alright, now the first thing I want to do is see if I can divide both sides by 6. Now if I divide both sides of this equation by 6, I'm going to end up with fractions, and I don't want to end up with fractions. So instead, I'm just going to go ahead and square both sides. When I do that, recall that means I've got 2x minus 4 times 2x minus 4 is equal to, now when I square the 6, that's just going to leave me with 6 times 6, so 36 times the square root of x minus 4 squared just leaves me with x minus 4. So I have 36 times that x minus 4. Here I need a FOIL out, so I have 2x times 2x, that gives me 4x squared. 2x times negative 4 gives me negative 8x. Negative 4 times 2x gives me negative 8x. Negative 4 times negative 4 gives me a positive 16. 36 times x gives me 36x. And 36 times negative 4 gives me negative 144. Alright, at this point I'm going to combine my like terms on my left side. So I have 4x squared minus 16x plus 16 is equal to 36x minus 144. So I'm going to add 144 to both sides because I want to set this quadratic equal to 0 so I can factor it out. And I'm going to subtract 36x from both sides. When I do this, this leaves me with 4x squared minus 52x plus 160 is equal to 0. Now before I start factoring out this quadratic, I'm going to look at it to see if I have a greatest common factor that I can factor out, or I can divide this whole equation by. And if I look, I can divide this whole thing by 4. When I do that, that leaves me with x squared minus 13x plus 40 is equal to 0. So factoring this out, I've got a coefficient of 1 in front of my x squared. So I need two numbers that multiply to give me a positive 40, but add up to give me a negative 13. So they must both be negative, and that would be a negative 8 and a negative 5. So I end up with x equals 8 and x equals 5. Now once again, I want to check these to make sure that they hold true. So we can plug them into our original equation, which means I've got the square root of 3 times 8 plus 1 is equal to 3 plus the square root of 8 minus 4. So square root of 24 plus 1 is equal to 3 plus the square root of 4. So the square root of 25 is equal to 3 plus 2. So I get 5 is equal to 5. So that first one holds true. Now be careful. Something I see very often is that people see that the first one holds true and works. They assume the second one does not. You still need to plug it in to check. So let's go ahead and do that. So that means for the second one, I'll go ahead and do that in a different color. The square root of 3 times 5 plus 1 is equal to 3 plus the square root of 5 minus 4. Right, so that means I've got the square root of 16 is equal to 3 plus the square root of 1. So I've got 4 is equal to 3 plus 1. So 4 equals 4, and both of these in fact hold true. So for this particular problem, I had two solutions, x equals 8 and x equals 5.